Welcome to Bad at Goodbyes. Each week on our show, we spotlight species from the IUCN Critically Endangered Red List. These are plants and animals with decreasing populations, nearing the edges of extinction. So we'll share species research, information, and conservation proposals. And then we'll spend part of the show opening a space for contemplation and awe. We'll perform a soundscape of gentleness, of reflection, and maybe of grieving. Without conservation activity and societal shift, many of these species will not survive the 21st century. And so perhaps we might acknowledge their journey with a moment of our attention, a recognition of our kinship, and with a commitment to personal and systemic change. Thank you for listening. On today's show, we consider the Greek Red Damsel. The Greek Red Damsel is a critically endangered damselfly native to southeastern Europe, specifically Greece and Albania. The Greek Red Damsel is a flying insect in the dragonfly and damselfly family. It has a long, slender, cylindrical body measuring roughly 1.5 inches in length. Its exoskeleton is a really rich, bright red, marked with dark vertical bands. Its anatomic form, like all insects, is divided into 3 sections: the head, the thorax, and the abdomen. The head is small and rounded, with large compound eyes on each side, providing a wide field of vision. Their eyes are reddish-brown at the top and yellowish at the bottom, divided by dark brown horizontal bands. Compound eyes are comprised of thousands of ommatidia. Each one is like a tiny lens. And so the Greek Red Damsel sees the world in a kind of mosaic. So instead of like one single clear image like humans see, the damselfly's brain combines all of these tiny dots into a composite view. This is an adaptation for subtle movement detection, ultraviolet light, and seeing high contrast polarized light, all of which is useful for flight navigation. The varied coloration of their eyes is thought to filter color and light, and so different ommatidium are tuned to accept or reject different color wavelengths. I find this so gorgeous and humbling that, like, for all of our human accomplishment, there is a world of sights, of light and color that is just like generally inaccessible to us. Between the eyes of the Greek red damsel are two bristly, short antennae. These are also sensory organs covered in fine hairs called sensilla, and they're primarily adapted in the damselfly to detect airspeed. This is a somewhat specialized adaptation, as many other flying insects rely on their antenna to sense smell, like butterfly, or to explore via touch, like beetles. Instead, the damselfly mainly uses its antenna for flight navigation. At the front of the Greek red damsel's head are mandibulate mouthparts. We've gone into detail about insect mandible on past shows, so for now let's just generalize their mouth as like a pair of horizontal pincers. The Greek red damsel is a carnivorous predator, and so these pincers are particularly strong, adapted to piercing and breaking open the exoskeletons of its insect prey. So that's an overview of the head. Next is the small middle section, the thorax, which is roughly a quarter of the damselfly's overall length, and bears 2 pairs of legs and 2 pairs of wings. The legs are long and slender with numerous spines, and all 4 legs are bent facing forward, adapted for grasping prey. The wings are translucent, with thin black veins throughout that provide structural support and flexibility for flight. Both pairs of wings, the forewings and hindwings, are similar in size and shape, and when at rest, the wings are held vertically together above the body, folded neatly above the abdomen. This is a trait that I note because this is a key way that entomologists can really quickly differentiate damselflies from dragonflies. Dragonflies keep their wings out horizontally, like lateral to the body, even at rest. The damselfly's thorax also includes powerful flight muscles and houses parts of their circulatory, nervous, and respiratory systems. The thorax is a brownish metal color, like a rust bronze, but a little shiny. And then the third section is the abdomen, from which our damselfly derives part of its name. This is a long, cylinder-shaped, 10-segment abdomen, and it's a vibrant red, marked with dark vertical bands. The abdomen houses parts of the digestive system, the nervous system, the circulatory system, as well as the reproductive system and the respiratory system. Damselfly breathe, they respirate through tiny spiracles. These are numerous little openings across the abdomen that take in oxygen from the air and expel carbon dioxide. And so the abdomen also houses the reproductive systems. Damselfly reproduction is remarkable. Males have a sperm production organ near the end of their abdomen, and then a secondary copulation organ on the underside of their second segment near the thorax. The female reproductive and copulatory organs are near the end of their abdomen, so to mate, the male must transfer sperm from its frontal abdomen to the female's posterior abdomen, like near the end. And they do so in flight. And so here's how this works. Damselfly abdomen are flexible at each segment. And so with the pair both facing forward, the male will bend his abdomen upward to grasp the female behind the head using a specialized clasping organ at the end of his abdomen. Then the female will bend her abdomen downward, so her reproductive organs, which are near the tip of her abdomen, meet with the male's copulatory organs sort of in the middle of his body. And so together they form a kind of wheel shape and remain so in flight for sperm transfer. Following sperm transfer, the male continues to grasp her head, guarding and protecting, while the female disengages to prepare for egg laying. Female damselfly have a specialized egg-laying organ called an ovipositor. And so the pair will fly together to a suitable nearby site, and using her ovipositor, the female burrows her eggs directly into the stems or leaves of watergrass, sedge, or water plantain, directly into plant tissue just above or just below the water's surface. The tandem pair often remain connected throughout this process, separating only after successful egg laying. Greek red damselfly do not form long-term pair bonds or like family units, and will mate with different individuals across their adult lives. And so the eggs, nestled in the plant tissue, will hatch in 1 to 3 weeks, and the new larvae are totally self-sufficient at birth. The larva is totally aquatic, with gills for breathing underwater and specialized mouth parts for catching underwater prey. It matures through a series of molts. Larval exoskeletons are hardened and do not expand or grow, and so as the larva matures and gets bigger, it must shed its exoskeleton. So before a molt, the larva begins to develop a new, larger, soft exoskeleton beneath its existing one. And then the old exoskeleton splits open, and the soft-bodied larva wriggles out of the old exoskeleton. And over time, this new exoskeleton hardens, and the larva has more room to grow before its next molt. And so after a series of underwater molts, over the course of 2 to 3 years, the damselfly reaches its final larval stage. The larva will climb out of the water, onto a plant stem or a rock, and again the exoskeleton will split open, similar to previous molts, but this time an adult damselfly emerges. This new adult is soft, pale, and its wings are crumpled and small. Quickly though, in the course of a single day, the exoskeleton hardens, its adult coloration develops, and the wings expand, soon able to fly and begin its mature adult life. This is a profound metamorphosis, a transformation from a wingless, water-dwelling, water-breathing larva into an air-breathing, winged adult capable of flight. This winged adult only lives 1 to 2 months, focused entirely on feeding and reproduction. The adult Greek red damsel feeds on other flying insects. It is a diurnal, carnivorous predator, so hunting during the daytime, preying on mayflies, moths, and smaller dragonflies and damselflies, which they capture mid-flight. They rely on their finely tuned eyesight to identify potential prey and use their antenna to sense wind current. And their strong wing muscles allow them to hover in place and then strike, intercepting their flying target. They hold their forward-facing legs in a kind of basket formation, essentially scooping their meal out of the air. Their strong mandibles crush and tear the prey's exoskeleton, which allows them to feed on it. In the dream, a swirl of color, fragmented, whirling, shuddering light, pixels, pointillism. And I hold my beloved, dressed in red softly, and we tumble together, flying and falling and flying and flying. In the dream. The Greek Red Damsel is native to southeastern Europe, to 3 distinct subpopulations in Greece and Albania. So there's one subpopulation in southwestern Albania, in the county of Vlora. There's one subpopulation on the Greek island of Corfu, and one in the northeast of the Grecian Peloponnese Peninsula. This is a Mediterranean bioregion with warm, dry summers and mild, wet winters. High temperatures reach into the 90s in the summer and lows average in the 40s in the winter. And the region sees a rough average of 30 inches per year of rainfall. The Greek red damsel's specific habitat is freshwater ecosystems. So these are clear brooks and slow-flowing streams with abundant vegetation. The Corfu habitat includes ditches and slow rivers, while the Peloponnese populations inhabit mountain brooklets. One study specifically suggests that the damselfly is unable to survive in habitats that dry out during the hot summer months, so it needs year-round, slow-flowing freshwater access. And though researchers have not directly correlated this as a habitat requirement, it's interesting to note that all of the remaining subpopulations are found less than about 15 miles from the ocean, so specifically the Ionian Sea and the Gulf of Corinth. The Greek Red Damsel shares its Mediterranean habitat with beach martin, European green toad, emperor dragonfly, soft rush, arrowhead, willow, golden jackal, spiked water milfoil, European water plantain, Sardinian warbler, pondweed, kingfisher, European otter, common reed, agile frog, water starwort, adler, swallowtail butterfly, kestrel, Greek marsh frog, Cleopatra butterfly, Balkan terrapin, hedgehog, sedge, mayfly, stonefly, stonewort, red fox, and many, many more. Both historically and currently, the Greek red damsel population is primarily threatened by habitat loss and degradation. This is a water management issue. The natural brooks and small rivers of its habitat have historically been drained, diverted, or profoundly modified for agricultural irrigation. And the modern construction of artificial concrete channels destroys all aquatic plant life, so rendering built waterways uninhabitable for the Greek red damsel. Water pollution is also a concern. Agricultural runoff, so pesticides and fertilizers, and urban wastewater contaminants will directly harm the larva of the Greek red damsel and overall degrade water quality, so reducing oxygen levels, which impacts the aquatic ecosystem that the damselfly depends upon. Human-induced climate change is an emerging threat. The increased frequency and intensity of summer droughts in the Mediterranean region affects the water level and even has dried out some of the small streams and brooks that the Greek red damsel requires. Increasingly severe drought conditions will lead to the direct mortality of larvae and loss of suitable breeding habitat. I think it's useful to note the ways in which these threats intertwine. So, for example, water extraction for irrigation lowers stream flow, making the remaining water more susceptible to higher concentration of pollution, and increasing the likelihood that the stream could completely run dry, say during a drought. Dragonfly and damselfly researchers across the European Union note that because waterways cross borders and water management is not site-specific, like agricultural overuse can affect habitats miles up and downstream. And so to address habitat degradation, we need more than just local site protection. Proper conservation will require integrated regional and perhaps even international water resource management policies alongside local site protection. Due to the very recent recognition of its endangered status, the Greek red damsel is not currently legally protected, nor is its habitat. There is, as of yet, no conservation activity for this species. The Greek Red Damsel has been considered critically endangered on the IUCN Red List since 2023, and their population is currently in decline. Our most recent counts estimate that less than 1,000 Greek Red Damsel remain in the wild. Information for today's show about the Greek Red Damsel was compiled from the Atlas of the European Dragonfly and Damselfly, Hydrobiologia, Volume 811, the International Journal of Odontology, Volume 9, the IUCN, the Journal of the British Dragonfly Society, Volume 26, Number 1, Journal of Zoology, Volume 317, Issue 1, Libellula, Volume 32, Issue 34, and The Science of Nature, Volume 112, Number 8. And so in a moment, I would like to perform some music in hopes of opening a space to be in contemplation of the other lives with whom we share our earth. I do not intend to put meaning upon or extract meaning from the Greek Red Damsel. Instead, I want this music to be a moment to express my human awe and an opportunity to consider my relationship to other life. Particularly, like the Greek Red Damsel, life that may near extinction. And so I will sit in the space of sound and awe and contemplation, and I warmly invite you to join me. I honor the life force of the Greek Red Damsel. I will commit its name to my record. I am grateful to have shared time on our planet with this remarkable being. And I lament the ways that I and my species have harmed and diminished this species. I grieve. And so in the name of the Greek Red Damsel, I pledge to reduce my consumption, my carbon footprint, and my wastefulness. I pledge to acknowledge and attempt to address the actual costs of my actions and inactions. I pledge to resist the harm of plant and animal kin and their habitat by individuals, corporations, and governments. I forever pledge my song to the witness and memory of all life, to a broad celebration of biodiversity, and to the total liberation of all beings. This has been Matic Goodbyes. Thank you for listening. Until next time, let's take care of each other and all of our kin. Bye.